Guys, how's it going? Again, the videos are best played at 1.25 speed. Google tends to slow down my voice on YouTube. Okay, so hey, listen, we're going to be looking at something called conduction and induction. And you're going to be able to look at the notes to help you decipher what I'm saying here, and vice versa. So, conduction is something that occurs, okay, when two objects touch each other and then the charges jump from one object to the next. So I'm going to give you a couple of some simple examples. Okay, so let's say I've got sphere A and sphere B. Okay, and I take and I know that this is a neutral sphere because I got there's no net charges here because I've got an equal number of electrons as I do protons. I'm going to make B, so the charge is Q is 0. Okay, Q is 0. Let's say I take this one and I give it, okay, and I give it 4 negatives and 2 positives. Well, Q, the charge, is going to be, well, these two cancel, is going to be -2 electrons. Okay, so now just as an aside, when we look at electrons, there are billions of them on the surfaces, and protons as well. So I'm simplifying the numbers now because it makes it easier to understand. So let's take a look. If I bring these two objects together, okay, if I bring them together, okay, what happens is I touch them together, and the number of electrons is dispersed between both of these objects. So if I touch them together and then I bring them apart, okay, I've got a situation that looks like this. Okay, look what I've done. I've taken a negatively charged sphere and I've touched it against a neutrally charged sphere, and because I touch them together they become one unit, and the one electron will jump over to this side. Okay, so what do I have left? I've got 1 electron extra here, and I've also got 1 electron left here. They become evenly split. Okay, and that's important to understand, that they become evenly split. So I touch them together, they come apart, the electrons distribute themselves equivalently across both of these metal spheres. Okay, an important concept to remember. And the other thing that you want to remember too is that the electron is the most fundamental source of electric charges. So meaning this, can you take an electron and can you split an electron into a half E? So does half E exists? Absolutely not. Okay, the smallest charge we can get and we can measure is 1E. Okay, so we cannot split the electron and get 2 half charges. Just so you know, I think in the homework questions you might have something on that. Okay, a couple other examples of conduction. Okay, so let's say that I have a sphere and a metal rod. Now, I'm going to give the metal rod some extra charges, meaning the metal rod has more electrons than it does protons. Now, what I'm also going to do is give this a neutral charge. Let's just say it's a neutral charge. Okay, meaning there's the same amount of electrons as there are protons. So I bring this close. You know, the process works like this. I bring this close. Okay, I bring it closer. Okay, then what happens is as I bring it closer, the electrons flee to one side and it becomes polarized. Okay, so that you might want to look as like step 1, becomes polarized. Okay, and then the next step is that this makes contact. Now, as soon as this makes contact, these guys want to balance each other out, meaning that one electron here is going to jump from there. Okay, so if they've touched now and they are now brought apart, okay, excuse the size differences, I'm going to have one electron that is to have jumped over to the sphere, and I have 3 electrons on this side left. So I've charged this by conduction, I've touched it, and I've made the charges different on this sphere. Okay, you see what happens there. Okay, so that is conduction. I mean, that's it in a nutshell. You may want to read the section to get a little more detail on that, but I mean, that's conduction in a nutshell. And again, please look at the notes. Please look at the practice problems. And listen, I didn't. I want to let you guys know that as you're reading along the notes, you can also click the notes, and then there's also explanations from the folks at New Jersey about some of these topics that you have. So that would be something that you might have to take a look at too. So this video is nice and short. We're about 6 minutes. The next video is going to be on induction. Now, induction is a bit more complicated, and I'm going to get you started with it, actually. So induction's a bit more complicated, and in this video, I'm going to mention something called a ground. Now, now you live in a house, probably, hopefully, and your house has electrical circuits all around the house, all embedded within the walls and the ceiling and the basement. You have an electrical panel. What I'm going to tell you quickly is that your house has something called a ground. Your house, if you look for it, there is either a rod that's pounded 4 feet into the ground, which a ground wire is attached to, or the ground in some of the older houses is actually the pipes. So the metal pipes that run onto the street for the water sources. So if you have a public water supply, most likely your ground is going to be a water pipe. Now, let's look at what a ground is. Super quickly, I'm just going to draw a quick picture here of that sphere we were talking about. Okay, and remember, I called this the ground. Now, the Earth is a very big object, and the Earth is very, very neutral. Okay, so, you know, if I were to shove an extra 10 billion electrons into the Earth, it really wouldn't notice it that much. It's because the Earth is so big. So here's the deal. We know already that this is an insulated rod. Okay, this means that nothing's going through it. No electrons are going through it. But let's say I were to take a copper grounding wire and I hook it to the side of the sphere and I bring it down to the ground. Hey, look what I've done now. I've given a path for electrons to either go up or down this wire. Okay, so this ground here is a very neutral object because the ground is actually the Earth itself. And as you guys know, the Earth is very big. The Earth is going to be able to let us do something that's called charging by induction. So this is a bit more complicated. The next video may be about 15 minutes. Sorry about the length, but we're going to talk a bit about what induction is and how to charge something like a sphere by induction. So because I've added a copper wire here to the ground, this sphere actually has to act like the Earth. Meaning, if I hook up this wire here, this sphere by itself has to act like the Earth, which is going to remain very neutral. Okay, so I'm going to leave it there. We got about 10 seconds left till about 10 minutes. Next video is on induction.